Jason has 50 coins in his pocket, and the coins are composed of quarters and dimes. And the total value is $8.45. So how many of each coin are there? Okay, so we're going to look at the last sentence to determine our variable. So how many of each coin are there? So we're going to let x equals the number of quarters. And we're going to let y equal the number of dimes. Now this problem can be solved in actually two ways, because we need to make a relationship of quarters and dimes, the number of quarters and the number of dimes. And we can make this relationship here with the number of coins here. So that's one relationship. And we can make another relationship based on the total value of the coins. So my first equation is going to be based on the number of coins. Okay, so here x and y are the actual number of coins. So my first relationship is going to be x plus y equals 50. Then I need to come up with a second relationship, and the second relationship is going to be based on the total value. So my second relationship, so how do I calculate $8.45? Well, if x is the number of quarters, I'm going to multiply 25 cents times the number of quarters. And if y is the number of dimes, I'm going to multiply 10 cents or $0.1 times the number of dimes. And this is now going to give me the amount of money I talked about, because x is not money, it's the number of coins. But if I multiply the number of coins by the value of each coin, I get the total amount that's worth. And this is dollars plus dollars equals $8.45. So there are my two relationships. Once I have my two relationships, I can just put them into my graphing tool. So I'm going to go x plus y equals 50. And the other relationship works out to be 0.25x plus 0.1y equals $8.45. So when I graph this then, I know that I don't really need to worry about the negative parts of this graph. So I'm just going to graph it like this, and I'm going to maybe just go, my scale is going to be from maybe negative 20 to, let's say, 80, and my y scale is going to be from like negative 10, negative 20 to let's say 80, okay, something like that. And my graphs are going to look like this. So my red graph is going to be x plus y equals 50. So I can have 0 for x, and y is going to be 50, and it's going to look something like that. And the other relationship is going to be 0.25x plus 0.10y, and that's going to be a graph that looks something like this. Okay, and my intersection point then represents the number of coins. Okay, so remember that x represents the number of quarters, and y represents the number of dimes, not the value of the dimes, but the number of dimes. So when I solve for that intersection, so I look for that intersection point on my graph, it's going to be 23, 27. What that means is the number of quarters equals 23. Okay, that's my x. And then my y is going to be the number of dimes. That's equal to 27 dimes. And if I calculate this out, 27 dimes is $2.70. 23 quarters, well, I know that's going to be $5.75. When I add those together, I get $8.45. Yeah, that's exactly what I had. My quarters add up to 50. Yeah, that fits the first relationship. This must be my solution. And the solution is where the two relationships or the two graphs intersect.